In this video, we're going to talk about properties of rational exponents. So first, our first example says 13 to the 1/3 times 13 to the 1 over 6. What is this? Well, the base is the same, and when you multiply, you have to add the exponents when the base are the same. So it will be same thing as 13 to the 1/3 plus 1 over 6. And what is the common denominator? That's 6. So you end up getting 13 to the 2 over 6 plus 1 over 6, and that's 1/2. It's 13 to the 1/2. What about this example right here? Let's take a look at this example. First of all, you cannot multiply these two because they have a different base, 5 and 8. And if you recall, if you have a, b to the m, that's going to be the same thing as a to the m, b to the m. And if you have, like, let's say a to the x, b to the y, quantity to the m power, this will be a to the xm and b to the ym. So when you have this, what you need to do is you got to put it as 5 to the 1/5 to the power of 5 times a to the 1/4 to the power of 5. So you end up getting 5 times 8 to the 5 over 4. Let's take a look at the example right here. This is similar to what we did last time. Again, you cannot multiply these two because this is a base of 12 and this is a base of 9. But we do have an exponent outside. So you will get 12, 3 times negative 1/3, which is negative 1, times 9 to the negative 1. So what is this? This is 1 over 12 times 1 over 9, which is 1 over 108. What about this example right here? When you divide, what do you do with the exponent? You subtract. So let's say you have a to the m over a to the n. When you have the same base, it's going to be a to the m minus n. And what is the exponent over here? It's 1, which is the same thing as 9 over 9. Why did I choose 9? Because the denominator here is 9. So it's going to be the same thing as 8, 9 over 9 minus 1 over 9, which will be 8 to the 8 over 9. For this example, recall that quantity a over b to the power of n is the same thing as a to the m over b to the m. Well, they're going the other direction. So for example, we could rewrite this as 56 over 8 to the power of 1/4, and then the whole thing to the third power. So what is 56 divided by 8? That's 7. So it's 7 to the 1/4 to the power of 3. You have a 2 exponent next to each other, so you multiply, you get 7 to the 3 over 4 power. And that's your answer. For this example, we need to apply the nth root of a times nth root of b is the same thing as nth root of a times b. So basically what we could say is that this is cube root of, since that's a cube root and this is a cube root, it will be cube root of 4 times 128. Now, we need to break down 128. That's 4 times 32. And that's 4 times 8. And that's 4 times 2. And that's 2 times 2. The reason why I broke it like that is because you could rewrite it as now 4 came from 4. What about 128? It is 4 times 4 times 2 times 2 times 2. This cube root means you need 3 of the same kind to come out. So 4 comes out and 2 comes out. So 4 times 2 will be 8. You have fifth root of 192 over fifth root of 6. So this one is the same thing as fifth root of 192 over 6, which is fifth root of 32. And when you break down 32, it's going to be 2 times 2 times 2 times 2 times 2. You have 5 of, now this index 5 means you need 5 of the same kind to take it out. And you have 1, 2, 3, 4, 5 2s, so 2 comes out, and that's your final answer. By the way, what if it came out to be something like this? Let's say you got 2 times 2 times 2 times 2 times 2 times 3 times 3. If your final answer came out to be like that, well, the 2 could come out. But then 3 and 3 has to stay inside, so 3 times 3 is 9. So that would be the answer, if the case was like this. Now you want to simplify cube root of 500. So let's break down 500. It's 5 times 100. That's 5 times 20. And that's 5 times 4. So 500 is the same thing as 5 times 5 times 5 times, and then 4 is 2 times 2. So what can come out here? 5 comes out, because you need 3 of the same kind to come out, since index is 3. What about 2 2s? Well, you need one more 2 to come out, so since we only have 2 2s, they have to stay inside, so it becomes 4. So the answer is 5 cube root of 4. How do you simplify 2 over radical 3? In other words, how can we get rid of radical on the bottom here? In order to get rid of, take out 3, you need to multiply another radical 3 to the bottom. Since whatever you multiply on the bottom, you have the same thing to the top to make it equivalent. So what is radical 3 times radical 3? That's 3. 3 comes out. And 2 times radical 3 is just 2 radical 3. And you will notice that 2 over radical 3 is same thing as 2 radical 3 over 3. You could use your calculator to check that these two are the same. Now, what if you want to get rid of the radical on the bottom? First of all, we're writing this problem like this, 4th root of 19 over 4 doesn't really help us. You have 4th root of 4 is same thing as 2 times 2. So since index is 4, you need 2 more 2s to come out. So what you want to do is you got to multiply by 4th root of 4 on the bottom. And see, since we multiply 4th root of 4 on the bottom, you got to do the same thing on the top. So now you get 4th root of 19 times 4. And then 4th root of 4 times 4th root of 4 is 2. Remember, our goal is to get rid of the radicals on the bottom. And you cannot break down 19, and breaking down 4 doesn't really help because since index is 4. So just multiply 19 and 4. And it's fourth root of 76 over 2. And be careful. You cannot, common mistake is students want to divide 76 by 2. However, this 76 is inside the radical. So you cannot divide 76 by 2. Either they both have to be outside in order for you to divide the numbers. So this is our final answer. In this example, we need to simplify 1 over quantity radical 7 minus 2. So multiplying the bottom by radical 7 will not help you get rid of the radical because you will multiply 2 times radical 7. So you still end up with a radical. When you have a denominator like this, you got to multiply by the conjugate. And what is a conjugate? Conjugate is everything's the same except for the sign in the middle. So for example, conjugate of radical 7 minus 2 will be radical 7 plus 2. And what's the conjugate of negative 3 minus 2 radical 5? Well, like I said, everything is same except for the sign in the middle. So it's negative 3 plus 2 radical 5. Let me give you one more example. What if you have 8 minus radical 5? What is the conjugate of that? It will be 8 plus radical 5. The nice thing about conjugate is that when you multiply these two conjugates, the middle terms cancel out. So the conjugate, radical 7 plus 2, and you got the same thing on the top. So 1 times radical 7 plus 2 is just radical 7 plus 2. What about the bottom? What's radical 7 times radical 7? That's 7. What's radical 7 times 2? That's 2 radical 7. What's negative 2 times radical 7? Negative 2 radical 7. Negative 2 times positive 2? Negative 4. What happens to the middle term? They're opposites. So when you add them up, they cancel out. So you end up getting radical 7 plus 2 all over 3. And that's your final answer. Now, when you add and subtract radicals, you got to remember 2 things. When you add and subtract radicals, they need to have same index. And they must have a same radicand. The number over here is called index. And whatever is inside the radical is called radicand. So for example, you have a fourth root of 10 plus 7 fourth root of 10. They both have the same index of 4. And what is a radicand? 10. So we could add, what's the coefficient over here? 1. So it's going to be 8 fourth root of 10. It's like very similar to adding like terms. Can we add these two? What is a radicand? 8. What about index? Well, the index is 5. Because if you change 8 to the 1/5, that's 5th root of 8. So what is in this case? It's 2 plus 10, which is 12. Quantity 8 to the 1/5, which is the same thing as 12, 5th root of 8. But you could leave it like this because the original question had a rational exponent. What about 4th root of 48 minus 4th root of 3? They have the same index, but they do not have same radicand. So we cannot subtract unless we could kind of manipulate so that it will be, they will both have the same radicand. So let's look at 48. Let's break it down. You get 3 times 8. That's 2, 4, 2, 2. So you have 1, 2, 3, 4 2's. So 2 can come out. And what stays inside? 3. Now notice, they both have the same index, and now they both have the same radicand. So what's 2 minus 1? That's 1. So your final answer is 4th root of 3. So just because they look like they don't have the same radicand, sometimes you need to really break it down and see if they will end up having the same radicand.